Hello everyone and welcome to today's session on artificial neural networks by Intellipaat. So, what is an artificial neural network? An artificial neural network in the field of artificial intelligence is something which attempts to mimic the network of neurons that makes up a human brain, so that computer will have an option to understand things and make decisions in a human-like manner. The artificial neural network is designed by programming computers so that it behaves simply like an interconnected brain cells. In this session, we will learn all about artificial neural network. But before we begin our session, do not forget to hit the subscribe button and click the bell icon. So, without further ado, let's begin our session.
Let us move on with the first topic. What is an artificial neural network? First of all, the name neural network is inspired by the working of the human brain. The individual units in the human brain are called as neurons, and the interaction between these neurons is achieved through a network called as neural network. Since we are trying to simulate this interaction in the human brain within a computer, it is more accurately called as an artificial neural network instead of just the neural network. And it is sometimes also called as a simulated neural network, or SNN for short. In the image you see below, left side, we have the structure of a typical neuron, wherein the input is taken through the dendrites and then passed along to the axon, that is the tail part of the neuron. And this structure of the neuron is converted mathematically on your right side, which is the structure of an artificial neuron. The inputs are basically x1 to xn, and for each input there is a weight associated with it, which ranges from W1 to Wn. And then there is one more factor called as a bias or threshold, and if the inputs reach certain threshold, a set threshold, then it is passed on along the summation function and activation function, and finally to the output. The human brain has a biological neural network that has billions of interconnections. As the human brain learns, these connections are either formed, changed, or removed, similar to how an artificial neural network adjusts its weights to account for a new training example. This is the reason why it is said that practice makes one perfect, since a great number of learning instances allow the biological neural network to become better at whatever it is doing. We will be learning more about how an artificial neural network works in the further topics. Artificial neural networks are a subset of machine learning, which is in turn a subset of artificial intelligence as a whole. These artificial neural networks are at the heart of deep learning. Some people use artificial neural networks and deep learning interchangeably, but deep learning algorithms are just artificial neural networks with multiple hidden layers which are present between the input layer and the output layer. Now we will be learning about the layers in the upcoming slides. Artificial neural networks are comprised of node layers containing an input layer, one or more hidden layers, and an output layer. Each node or artificial neuron connects to another and has an associated weight and threshold. If the output of any individual node is above a specified threshold value, that node is activated, and in turn it sends data to the next layer of the network. Otherwise, no data is passed along to the next layer of the network. Neural networks rely on training data to learn and improve their accuracy over time. However, once these learning algorithms are fine-tuned for accuracy, they are powerful tools in computer science and artificial intelligence, allowing us to classify and cluster data at very high velocity. Tasks in speech recognition or image recognition can take minutes versus hours when compared to manual identification by human experts. One of the most well-known neural networks that we have today is the Google's search algorithm. Alright, let us move on to the next topic, which is the history of ANNs. It all began in 1943 as Walter Pitts, a mathematician, and Warren McCullough, a neurophysiologist, in 1943 researched and wrote a paper describing how neurons might work, and then developed a simple neural network using electrical circuits. Later, scientists called as Donald Hebb, he was also a psychologist. He explained on the ideas, writing a book called as The Organization of Behavior. He wrote this book in 1949, where he proposed that neural pathways strengthen with each successive use. He wrote a line in his book which goes something like this: when one cell repeatedly assists in firing another, the axon of the first cell develops something called as synaptic knobs, or if they're already present, they are responsible for enlarging them. So these are in contact with soma of the second cell. Later in the 1950s, author Samuel, He was an IBM researcher. He developed the first computer program capable of playing checkers. This checker playing program was also the first primitive version of machine learning. His design used a scoring function that evaluated the positions of the checkers, attempting to measure the chances of each side had of winning. His program eventually evolved into the min-max algorithm that is famous today. Later in 1957, a scientist named Frank Rosenblatt, he was also a researcher for the Cornell Aeronautical Laboratory. He merged the Hebb's model of brain cell activity with Samuel's machine learning concepts and created something that is celebrated today, which is called as the Mark I perceptron. Using neuroscience experiments that had been performed in the 1940s, Rosenblatt created a model of how the human neurons worked. Now, moving on to the next topic, we have types of ANNs. Neural networks can be classified into different types, which are used for different purposes, obviously. And here in this section, I will not be discussing the comprehensive list. Instead, I will be talking about the most common types which has general use cases in the real world. The first type is called perceptron. The perceptron is the oldest neural network that is known. It was created by Frank Rosenblatt in 1958, as I have mentioned in the previous slide. It has a single neuron and is the simplest form of a neural network. Data is usually fed into these models to train them, and then they are the foundation for computer vision, natural language processing, and other neural networks. The next type we have is the convolution neural networks. CNNs are similar to feed-forward networks, but they're actually utilized for image recognition, pattern recognition, and or computer vision as well. These networks harness principles from linear algebra, particularly matrix multiplication, to identify patterns within an image. So these neural networks, that is the CNNs, are basically used for image classification. The next type we have is the recurrent neural network, or RNNs for short. RNNs are identified by their feedback loops. As you can see in the image above, that is image A, we have the input layer, hidden layer, and the output layer. And in the bottom node of the output layer, you have something called as a feedback loop, which goes backwards. And this is the main characteristics of the recurrent neural network. And you can compare it with a regular neural network, which does not have a feedback loop. And all the inputs travel in a single direction, that is forward. These recurrent neural network algorithms are primarily leveraged when using time series data to make predictions about the future outcomes. The examples of the use of RNNs in the real world is stock market predictions and sales forecasting. Thank you for watching till the end, guys. Have a nice day.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.